Now we're going to look at example number 2. So prove vector u is perpendicular to vector v given these two values over here. So let's just do eg2 over here. We've added another example just to get our practice up for the this subtopic over here. So eg2 when we know that the dot product of two vectors equals to 0, that's when we know that they are perpendicular. So let's take the dot product of vector u and v. So u is 2, -3, and 4, and v is 5, 2, -1. So u dot v equals to 2 times 5, which is 10, minus 6, minus 4. 10 minus 10 equals to 0. Therefore, u is perpendicular to v. Relatively straightforward, easy question. Now we're going to do example number 3. I'll just do it over here. So eg3, it is known that vector p, we have alpha 1, 2, and vector q, alpha minus 1, 2, -4, are perpendicular. Find all values of alpha. Okay, so we know that these two vectors are perpendicular to each other. Let's take the dot product. So p dot q equals to alpha multiplied by alpha minus 1, which will be alpha brackets alpha minus 1 plus 1 times 2 plus 2 minus 2 times -4, which will be -8, minus 8 in this case. Alpha squared minus alpha plus 2 minus 8, which then gives me alpha squared minus alpha minus 6. We've got a quadratic equation. Now let's solve for alpha over here. So to solve alpha, take the quadratic formula. We have minus b, which will then, so alpha equals to minus b. So minus 1, so it would be 1 plus minus square root of b squared, which is 1, multiplied by 4. So b squared minus 4ac, so multiply by -4 times 1, which is -4, times -6 is 24. 24 plus 1 is 25, all upon 2. Therefore, alpha equals to 1 plus minus 5 all upon 2. So alpha equals to 1 plus 5 is 6 upon 2, alpha equals to 3. Or alpha equals to 1 minus 5 is -4, divided by 2 is -2. So we've got two values for alpha over here. Next step is we sub in this into this over here. So when alpha equals to 3, we have p then becomes vector p equals to 3, 1, 2, and vector q equals to 3 minus 1, 2, 2, -4. And then when alpha equals to -2, in this case, we go p equals to -2, 1, 2, and q equals to, sorry, this will all be 0 because the dot product equals to 0. Q then becomes -2 minus 1, -3, 2 minus 4. So that is how you do these 3 examples in relation to the dot product.